Welcome everybody to lesson 23. Today we're talking about linear systems and inequalities. These can sound like big words, but it's just a different way of looking at some equations of a line and looking at some symbols. Again, it's different terminology. That's just memorizing rules and knowing that if you see a certain symbol, it means that we have to do a certain thing. It's going to be just creating those associations. Let's review. What is a linear equation? A linear equation is an equation that makes a straight line when graphed. So we have an example there, y equals 2x plus 1. That's our equation of a line. It takes the format of y equals mx plus b. We have a slope and we have a y-intercept. We have an m and we have a b, where m is 2 and b is 1. What is a system of linear equations? A system is simply two equations at the same time. So when you think about a graph, when you think about a linear system, it's just a graph with lines on it, more than one line on it. So here's an example. You have a y with 2x plus 1, y equals negative x plus 4. Those are two equations. That means we have two lines. A system always asks, where do the two lines meet? The meeting point is called the solution. Why does this matter? Systems and inequalities help us in real life. And here are some example ways it can apply to real life. So this can help when we compare pricing plans, if we plan budgets, if we model real life limits, and help us make decisions. So solving systems graphically. So when we talk about solving linear systems, it means finding that meeting point. Whenever we talk about solving a system, finding a solution, it simply means looking at the graph, looking at the two lines, and finding where they meet. That's it. It sounds complicated, but it's just finding that meeting point, that intersection. That's called the solution. So when we solve it graphically, when we find the intersection, you have to graph both lines, find where they intersect. The intersection point is the solution because it makes both equations true. So the example there in brackets, we have two equations of a line. That means we are working with two lines. If you graph both of those lines on graph paper, the intersection they have, where they meet, is this coordinate, 2, 3. That's where they meet. So the answer, the solution of that system is this. The solution is 2, 3. That means when x is 2, both equations have a y of 3. That's where they're meeting. There are 3 possible results when you're graphing systems. When we're graphing two lines, there's 3 possible solutions. One is there's one solution. So that means that the lines cross one time and there's one intersection point. The next is that there's no solution. No solution means they don't meet. They don't intersect. If that happens, they're parallel lines. They never meet. They always run the same direction. And infinite solutions means it's the same line and they overlap completely. They're not separate lines. Interpreting systems in context. So when we talk about a system, these linear systems working with two lines, it's usually in the context of a word problem. Here's an example. Gym A and Gym B. Gym A charges y equals 20x. Gym B charges 10x plus 50. X is the number of months and Y is the total cost. So it depends on how many months you're going to this gym. And, we're using the system to see what's better. What gym should we go to? Which one is more affordable for us? If we graph both of these lines, they meet at 5,100. They meet at this spot. So how do we interpret that? That means after 5 months, because this is X, and we know X is the number of months, that means after 5 months, both gyms cost $100. That's where they meet. That's their intersection point. So after 5 months, both gyms cost $100. So before 5 months, one gym is cheaper. After 5 months, one gym is cheaper. The intersection point answers the question. So now we're going to switch gears and we're going to talk about something called a linear inequality. Right now, up to now, when we talked about an equation of a line, it always has an equal sign. When we talk about a linear inequality, we're just changing the sign we're using. We're taking out the equal sign and we're putting in a greater than, less than. An inequality is like an equation, but instead of equals, it uses greater than, less than, greater than or equal to, that's what that sign means, or less than or equal to. So an example is y is less than or equal to 2x plus 1. So that means all the values of y are less than or equal to the line, because this is the equation of a line. So all of the y values are less than or equal to that line. That's what this is saying. When we graph these linear equations, there's certain rules we have to follow, and there's always 4 steps. Step number 1, you always graph your boundary line. You always graph what would be the equation of a line. And that boundary line is always this format, y equals mx plus b. If the symbol is the greater than, less than with the equal sign, the line will be drawn as a solid line. If the symbol is greater than, less than with no equal to, it's drawn as a dashed line. That is simply just a rule we have to follow. Step 2 is you're shading the correct side and you're using a test point, 0, 0. And that, if it makes the inequality true, you're going to shade that sign. And this will make sense when we work on it in the example question. But right now, I'm just going to read through this just to get familiar. So we have an example here that we can read through. If y is greater than x plus 2, let's just think right now about what steps we would have to do. In this example, the first thing we do is we have to draw our boundary line. And our boundary line would be y equals x plus 2. We're keeping our line the same. We're just putting y equals, and that's our boundary line. That's step 1. Step 2 is we would test 0, 0. So we would take 0, 0 and input it into our equation. So that's our equation, y equals x plus 2. I'm just input our testing point, 0, 0. We found both signs. Now let's look at our inequality. Is this true? Is 0 greater than 2? The answer is no. So you would shade the opposite. You would shade on the graph whatever side makes that relevant. So now we're going to practice. we have two lines, y equals 3x, y equals negative x plus 4. We're going to graph both and see where they meet. Here's our lines. So the blue line is our first line, y equals 3x. Orange line is our second line, y equals negative x plus 4. When we look at this graph, we want to see where do they meet? What is the solution to this system? We notice the intersection point is this. That is the solution to this linear system. And we know this has one solution. It's meeting in one spot. Number 2 is asking us, can we identify the type of solution? Remember, we have one solution, parallel, infinite. So when we look at these two lines, what do we notice? We notice m is 2. We notice m is 2. They have the same slope. If two lines have the same slope, that means they are parallel. They're going in the same direction. So that is what we can notice and identify the type of solution in that way. Number 3, we're going to look at this inequality. Y is less than or equal to negative 2x plus 3. So first we have to decide, is the line dashed or solid? If we go back to our rules, we will notice here it says if we see the greater than or less than sign with the equal to, it's a solid line. That's just a rule we have. So the answer is solid. It's a solid line. Why? Because the equal to is included. Now, down here, it's showing us the answer. But over here on this side, I just want to make some notes. Whenever we look at the inequality, we always have to think about the 4 steps. Step number 1 is to graph the boundary line. In this format. So in this case, we have to graph and then we have to, the second step is to notice, do we need to make it solid or dashed? Then we test our point. To see if the inequality is true, to see if the statement is true. And then we have to shade. So we graphed our boundary line here. We graphed the 2x3. That's this line right here. I'm just going to draw over it. That's that line. That's going all the way across. That's our boundary line. We know it's solid because the inequality is showing us this sign. So we know it's a solid line we had to use. And now we have to test our point to see what is true and what we have to shade. So let's use our test point. So our point is let's go back to our inequality, take our sign, Is this true? Is 0 less than or equal to 3? The answer is yes. 0 is less than 3. So that makes this inequality true. So we tested our point to see if it's true. We got our answer. Yes. Now we shade. So we know that we have to shade below the boundary line because it is talking about 0 being less than. So which side do you shade? Under the line, because it is using less than sign. And the less than sign with that statement is true. Now I want to make a note just over here. When it's in this format, this is our line. That's our line. The y less than or equal to negative 2x plus 3, when it's written in the inequality, that's showing us a region. So one shows us the line, one shows us the region we have to shade. So many notes on this page, but we can even make another note and we can say, if ever it's saying less than, we can shade below. If it's saying greater than, we shade above. Now, do you have to be an expert in these linear systems and linear inequalities? The answer is no. Should we be familiar with the relationship and how everything can interact together and get a general conceptual understanding? Yes. And I hope that's what happened for you today. Thank you. Great job. And I will see you next lesson.